going to be solving systems of linear and quadratic equations. So most of them will look like one of these three if you were to graph them. We're not always graphing. Okay, so it's a parabola and a line. Your solutions are where they intersect, those coordinates. It might be two of them. It may be one. It may not be any. So that's what they would look like if you were to graph them. We also have some occasions where you'll have two parabolas. So two U-shapes intersecting somewhere. We'll only have one example of that. Most of them will be one linear, one quadratic. All right. Now we're going to start off with the algebraic ways of doing this. Instead of graphing first, we will end on graphing. Okay, because that's generally not the first choice. Your other choices algebraically are substitution or elimination. Now in Algebra 1, 2, you should have been taught this with two linears. So you had two straight lines, you're trying to find where they crossed. Graphing is a method, substitution is a method, elimination is a method. But it's probably been a while since you've done either one. But it's applied a little bit differently with one quadratic and one linear. So what does it mean in the English language to substitute something? To replace it. Substitute teacher replaces me for the day. Okay. So I'm going to substitute because I can't solve for y and x at the same time. I have to solve for one of them and then the other. So the goal is to remove one of them temporarily to solve for one of the variables, then we will solve for the other one. Now, in order to substitute, you need at least one of the variables to be isolated from everything else in only one of the equations. Okay. For instance, this y is by itself and it's equal to everything else. Okay. That is best case scenario. And some of your homework problems, you'll get to pick which method you want to use, but you'll have to do an algebraic one. So since y is equal to this entire quantity, make sure you take good notes today. You should always take good notes, but even more so. I'm going to substitute that whole quantity. So I'm dealing with just x's. I'm going to replace the y in the first equation with that trinomial. Then the y's will go away temporarily. Okay. So I'm going to substitute that whole quantity in for y because it's equal to y. So that's going to look like this. So I'll have x squared plus 11x minus 12. That has taken the place of y. Then after it, I have a minus 30 equals 12x. So all of this was where that y was in the first equation. I just replaced it. Is everyone at least noticing that that is where this was? Okay. Reason being, now I can deal with just the x's, and then I'll deal with the y's after I find the x's, because these answers should be in coordinates. Now is where we're into solving. We've been doing solving for 2 weeks now. Okay. You have multiple methods. Okay. You have factoring, you have completing the square, you have the quadratic formula. Okay. I'm guessing most of you wouldn't, your first pick would not be completing the square. If I had to guess. Okay. Just from teaching a long time, that tends to not be the case. Generally people rely on factoring, but that only works if it is factorable, or the quadratic formula, which we just did. For both of those, it has to be equal to 0 though. It's not. So how do we make it that way? Subtract 12x. So that'll put a 0 here. Now in the same step, you can combine these like terms because they're already on the same side. So get it down as simple as possible. So we would have x squared, 11 minus 12 is a negative 1x. And what's negative 12 minus 30? Negative 42. And that's equal to 0. Now, I'm not going to promise you that these will be factorable, but most of them likely will be. Okay. So from here, you can use the quadratic formula, or you may factor. I will tell you if it's factorable, hopefully we're pretty fast at factoring, but if factoring is not your strength, then use the formula. Okay. Just since it's probably at least been a couple days since some of you have factored, depending on your retakes and stuff. But this is factorable. But if you want to use the formula, you're more than welcome to. What factors of negative 42 have a difference of 1?
7,
Negative 7 and 6. So we have an x minus 7 and we have an x plus 6. Or you use the quadratic formula. You will get the same answers either way, as long as you do it right. Okay, if you did the quadratic formula, a is 1, b is negative 1, c is negative 42. Plug it in and simplify. Okay. Now I've factored it. Okay. How do I solve? Did this last week. set each vector equals 0. And you isolate x. Okay. How would I isolate x on the first one? Add 7, so what would I get? X equals 7. If you remember, it should be the opposite sign of how it is in the factor. What's the other one?
X equals -7.
Now, that is half the answer to this problem, because these are coordinates. So one of them is 7 comma something, the other one is -6 comma something. But we have the x values now. If you know x values, how do you find y values? Plug it in. Okay. Now you can plug these into either the first one or the second one. It should come out the same either way. So you guys tell me, which one would you rather do?
First one.
The first one? Okay. If you want to do the second one, just make sure you get the same number. Okay. But I'm going to start off with 7. So I'm going to plug it in where the x is in the first one, since that's what we chose. So we'll have y minus 30 equals 12 times 7. And then you have to solve for y. What's 12 times 7? 84. How do we solve for y? Add 30. What's 84 plus 30? 114. That is the y value that goes with the 7. Okay. Now if we were graphing, that would take a while to get to 114, which is why we have the algebraic methods. Okay. We do the same thing with the -6, because we use that y value also. So again, you can do the first or second one. A lot of people tend to pick the linear one just because less x's, but it should not matter. If we plug 7 into here, we should get 114 also. What's 12 times -6? -72. Then we would add 30 and get what? -42. So that is the y value. So that is where those two graphs would intersect. We'd have a parabola and a line going through it at those two. Okay. So while you guys are finishing up writing that, we substituted what y was equal to, so you need at least one of the variables isolated. If both y's are isolated, you can just set them equal to each other. And then start moving stuff around to set it equal to 0. Again, the majority of them should be factorable, but I'm not going to promise you that all are, because I don't think I can make that promise. Okay. So if it's not factorable at this point, use the quadratic formula, because then you'll get 2 answers. But I think majority of them would be factorable. That is substitution. So we substituted once, set equal to 0. We technically substituted these two in again to find the y's. Okay. We're going to use the other method now. It's called elimination. But is there any questions before we do that? Okay. Now elimination again. Okay. You did learn this in Algebra 1 too, but it's probably been a while. Now I'm going to erase this in a second, but elimination is similar to how you first learned adding larger numbers in elementary school. So if you had 54 plus 303, what would you do? We would add the ones column, correct? Okay. Then we would add the tens column, then we would add the hundreds column, and so on. So everything needed to be lined up appropriately to do that. That is the process we're doing just with polynomials. Now previously, as far as you would have gotten, would be 2 linears, which is a little bit different than these are. But you want everything lined up with its like term. It is not currently, okay? The y's and the equal signs are lined up, but the x squared is not like terms with the 24x. That is like terms with this one's like terms with this one. Now we're going to adjust this a little bit because we can't eliminate it exactly as it is. Now again, I'm going to erase this in a second, but I'm going to show you why this does not work yet. Okay. Elimination, you should always be adding. Now what's y plus y? Again, I'm going to erase this in a second. Y plus y is 2y. Okay. Now, this one doesn't have any like terms, so nothing plus -x squared is -x squared. What is 24x plus 120x? 144x And 15 plus 15 would be 30. This does not help in any way because there's still a y and there's still x's. We need to solve for one at a time. Okay, so this doesn't help anything. So we need to adjust it slightly at the very beginning. Okay, so what we're going to do, the easiest way to approach these, you want to eliminate the y's. Now we got rid of the y's in substitution also. But to eliminate the y's, I need to make one of them a negative y. To change the signs, you're going to pick an equation and multiply by -1, but it has to be the entire equation. It should not matter which one you pick, but I'm actually going to pick the second one because if we're going to factor, we want x squared to be positive as much as possible. Okay? But it should not matter. So pick a line. I'm going to pick the second one. Okay? I'm going to multiply the entire thing by -1. It cannot just be the y, it has to be all the terms in the equations. Alright, the first one I did not adjust at all. So it's y equals, now I'm going to leave a space because there's no x squared. So we have to line up all our columns. We have 24x and we have plus 15. So we have our c terms, our b terms, and the a terms. This one just doesn't have an a term. Now after I distribute this -1, I have a negative y. I have a positive x squared. I have a negative 120x and I have a negative 15. So I changed the signs of all of them in that line. I could have done it to the first one instead. It should not matter. So in your homework, if you're doing elimination, just choose one. Because we should always be adding as we go. Alright, now the way this works out, this is the reason why we did that. A positive 1y plus a negative 1y is what? 0. Okay. Y plus negative y is 0. They're opposite signs. That is what we want. You want the y's to go away. Okay. Nothing plus x squared. X squared. Okay. 24x and negative 120x. Negative 96x. 15 and negative 15. 0. Now this will not always happen, but on occasion those will cancel each other out too. So this is what we're left with. Now we have only x's. Okay. So you want to start with one variable and then solve for the other later. Questions before we continue? Because that was the elimination part. Everything else is what we did previously. Yes?
Can you do this just by doing, like, plugging it back in, like just saying y is equal to 24x plus 15, and then, like, you know what I mean, like equals
Substituting?
to each other? Yeah.
So if it tells you, which I think you only have 9 problems in your homework because these take long. Okay. If it says solve algebraically, you can pick either method. So if you want to do substitution every time, by all means, the answer should come out the same. But I want to give you options. Okay. But yes, you could just set these two equal to each other. You should get the same equation. Okay. So you do have permission to use either, unless it says use elimination. Okay. Most likely, I will let you pick. Okay. Now, since it's equal to 0, I can use the quadratic formula, or I can factor. As review, how do you factor that? Is that a difference of squares? 96 is not a perfect square. So what do? We always do GCF first. Everyone forgets that for some reason. Okay. What's a GCF? X. So we still have 0. If we take out an x, what's left? X minus 96. So again, if you had done substitution, you would have ended up with the same equation. So either way, it factors the same. Okay. So if it's a binomial, or if it's trinomial, still check for GCF, but especially if it's a binomial. Now the last one, we set both factors equal to 0 to get our 2x values. We'd do the same thing, including that GCF of x. If I set x equal to 0, I just have 0 for that solution. If I set x minus 96 equal to 0, what do I get? Positive 96. Okay. These are your two x values. So we have a 0 for one of them, and we have a 96 for another. And this is regardless if we use substitution or elimination. It will always come out the same. You can even graph it, it will come out the same. Now 96 would probably take you a long time. Okay. So the elimination was just to get it to here. Alright. If you want to use substitution instead, you have permission to. Okay. Now, if I know x's, I need to substitute back in to find y. So the second half to find y's is the exact same regardless of which method. We need to plug in 0 and 96 to x's in one of the originals. Which one would you prefer? The first one, same. Okay. If I plug in 0, y equals 24 times 0 plus 15. I would hope we could do that in our head. What is that? 15. Okay, 0 would cancel out with 24, leaving that 15. So 0, 15 is one of them. Okay. Now the 96, I would strongly suggest the use of a calculator. We would do 24 times 96 plus 15. What's 24 times 96 plus 15? 2319. Would this take you a while to graph? Yes, we'd be here all day. Okay, which is why we have these methods. Okay. So the two coordinates are your answers. Alright, so I believe on the first several problems of your homework, it doesn't care what method you pick, it just says do it algebraically, which means this one or substitution. I'll let you pick. Me personally on these, I like substitution better, but occasionally I do elimination, it just depends. Okay. Questions before we do graphing? Now we will use the calculator to speed up the graphing process. Okay. So this is where we want to use the calculator for. Now we have a linear and we have a quadratic. How do you know the difference? How do you know which one's linear, which one's quadratic? Just looking at it. X squared is the quadratic one. Okay, linear means it's just x to the first power is the highest one. Now what we're actually going to do, and what I'd recommend if you had to graph, I would actually graph the parabola first. Okay, so we're going to use the calculator for that. So we're going to come up with an XY table. Alright, we're going to have quite a bit of points. I did adjust the axes on your graph before I put it in here so that you can see where you'd want to target your points. So we're going to enter in x squared minus 2x plus 6 into the calculator and use the table in there. Okay. So x squared minus 2x plus 6. Make sure it's a minus, not a negative. If you hit graph, it just shows you a sketch. Okay. Now if you're required to graph and show it by hand, if it says solve by graphing, then do that. I'll show you what the instructions would look like if you did. Now if you pull up your table, we're just going to use the numbers. I just want you to recopy it down. Now which ones would be the largest to fit on your graph, considering your axis on your paper? Would the y value of 30 fit? No, but would 21? Yes. So I want you to get everything from negative 321 all the way to 521. And there's a reason for it, so just copy down everything from that on the table and then we'll graph those. I have it on my paper in front of me, so I'm just gonna write them. So starting with negative 321, negative 214. We're gonna graph this in a second, but write all these down first. Negative 19, 06, 15, 26, 39, 414, 521. So you don't have to actually calculate all those. The calculator can pull points for you. Okay. Go ahead and plot those really quick. As accurately as possible. Your y-axis is going by 2, so graph it carefully. What coordinate is the vertex at, as review? Not 06, no. In your table, it's the one y value that doesn't match the others. 1, 5. The other ones are symmetrical on the other sides. Have your points visible because you'll want to find where the line is going to intersect this. So just be aware of that. So as your parabola, I'd recommend starting there because graphing a line does not take as long. Now, as review, since it's been a while since we've graphed any lines. So 4x plus 1, that is in slope-intercept form. Where do you start your graph?
1.
At 1. Okay, so I'm going to do this one in a different color. This is in y equals mx plus b. You start at b on your y-axis. So positive 1 would be your first point on your y-axis. Okay, now it's in between numbers because it's by 2s. I don't want your graph to be huge. Okay. Now your slope is 4, which means where do we go from there? Up 4, 1 to the right. Okay, now be careful on your up 4 because it's by 2s on your y-axis. So you'll have to be aware of this. So we're at 1, so up 4 would be 2, 3, 4, 5. 1 to the right, there's our first intersection. What coordinate is that? 1, 5. Okay. So if your parabola is already there, you just graph the line until it intersects. Now this line is slanted, so is it going to hit again? Just further up. If I connect these dots and keep going, is it going to hit the curved line? Yes, it will, so you need to keep going. Okay. So we're at 5, up 4 would be 6, 7, 8, 9, right 1. We haven't hit it yet, but it's closer.